Think again. Every line of code hides a secret world beneath the surface, the bytecode. When you understand how Python really runs, you gain sharper tools for debugging, smarter ways to profile, and insights that lead to real performance improvements. This is the journey from beginner to Pythonista. When you run a Python file, it goes through several steps. It loads the source code, it tokenizes it, it makes an abstract syntax tree, it compiles it into bytecode, and then it runs it. If you want a view of all the steps, I have another video you can watch after this where I explain each of the steps in turn. But in this video, I'm just going to focus on the bottom bit, the bytecode and the interpreter loop. Before I explain what bytecode is, you need to know what byte is. If you don't, I explain it in this video that you can watch next. The short summary is 8 bits make a byte, and a sequence of bytes is a bytes object. Watch that video if you don't understand. The Python source is compiled into structured bytecode data, and the interpreter loop reads that data and calls C functions to perform the actual work. So bytecode, the name is accurate, it's not a trick. It's code that's made up of bytes. So we're going to start Python shell, import a really simple function. This function returns 42. A Python function, as I said, is compiled to bytecode, and you can find that if you fish around in here. Python object has a private attribute called code. It has lots of interesting stuff. The one we're interested in right now is the code. So that is this function compiled to bytecode. So we'll look at what this thing is. So you can see it's 4 numbers, 149, 0, 103, 1. What do these numbers mean? Well, we can find out by importing the disassembler module. We go dis.opname, the dictionary of what all the numbers mean. So 149 means resume, and 103 means return constant. We have the operation code 149, then we have a 0, then we have the operation code 103, and then 1. Bytecode is a stream of bytes, and it's kind of like a tick-tock, tick-tock, tick-tock approach, where 149 is the code, and then 0 is the argument, and then 103 is the code, and 1 is the argument to that. What each argument means depends on what the code is. So in the case of resume, argument 0 means it's the beginning of a block. It's a normal start. Whereas with return const, the argument 1 means get the constant from the constants table with the index of 1. To make this clearer, we can have a little tangent. This is the classic 1951 Turner-matic invented in Sweden. In England, we don't really use these, we just queue. But I noticed in the Nordic countries, they have them absolutely everywhere. Places you wouldn't expect to need one. But this is the original one. So it's just a number, it's just a counter. You press the button, and it goes up by 1. And then when it gets to 99, it resets to 0. And it makes a horrible noise. This is more of a 1980s version. It's got a digital screen, LED screen. It's got little dots. So it's got a number, 26. He presses the button, it increments to 27.
27.
And then she says here.
Pound of German potatoes.
So she gives him the number 27 and says pound of potato salad. She's represented by the number 27. And a pound of potato salad. So we've got two things. We've got a code, 27, that's representing her, and then we've got pound of potato salad. So who we give it to, 27, and a pound of potato salad. Pound of German potato salad, what she said. So that's two things, code, 27, and an argument, pound of potato salad. And then he handles it. So he goes, and he gets the potato salad. This is the source code of CPython. This is the main interpreter loop which runs bytecode. So the bytecode comes in as a stream, a bit like Mickey Rourke, the wrestler, has got a stream of customers. Mickey Rourke is the switch statement here. It's given an opcode 27. That is matched to the relevant number, and then the handler gets the argument, pound of German potato salad, and it handles it. In the stream, we process the first byte, 27, and then we match it to the correct case based on that number. These constants here are all mapped to numbers. So it calls the right case, and then that case will get the oparg and anything else it needs to handle it. Like Mickey Rourke at the deli counter with the Turner-matic, he deals with the opcode 27, he matches it to the right person, to the right handler, and then the handler gets the argument, finishes, and then it goes back to the beginning, and it goes bing on the Turner-matic, and he gets the next customer, and he does it again, and he does it again, does it again. So you have an opcode, an oparg, opcode, oparg, opcode, oparg, and that processes the whole program. So this is the code of Python 3.10. I picked this because it's the kind of simple classic switch statement. In Python 3.11, Mark Shannon and friends does the Faster Python project, and they add some caching and stuff, but it's basically the same idea, it's just much clearer in this version. I'll cover the Faster Python project, it'll be a fun video for another day. Going back to our extremely simple function, we have resume 0, return const 1. So in the Python documentation, the dis this module page contains a wealth of information about this. So if we go to the Python bytecode instructions, it explains all the attributes that a operation has, like the opcode, the op name, etc. And if we go down to resume, so it explains what the argument does. So 0, the start of a function, which is neither a generator, coroutine, nor an async generator. So with 0, it can start with a clean slate, whereas with 1, after a yield expression, or 2, after yield from expression, or 3, after an await expression, it has to make sure it has all the context that it had before when it comes back. And then we have return const, and it just says that it returns with the constant at index consti. So the index, which is 1 in ours, from co-constants to the caller of the function, which is 42. So it returns 42. This function has two constants, 42 and none, because none is always available in case the function gets to the bottom without returning anything. It will return none by default. But in our case, it uses 42. So 42 is the first index. 42 is at index 1 in the constants table. I'll try and make this a bit more clear. So with our function, the answer to life, universe and everything, return 42. The program starts with resume, 0, fresh start, and then the first line of code that actually does something. We return the const with the argument of 1, and the argument of 1 is the index in the constant table. Our constant here is 42. We're returning 42. And you can see that bytecode is a programming language, but it's a different programming language. So the source code of the Python is compiled into this bytecode language, and it's the bytecode language that the interpreter runs. I mean, some computer scientists call it the virtual machine, but kind of distinguish between Python and the Java virtual machine, people tend to call it just the interpreter. So let's do a slightly more complicated function. So this one got more complicated. So this one has an argument. We take a stock, and if the stock argument is positive, we launch into space, and if it's not, like it's 0, then we remain in stasis. We have an operation, an opcode, then we have an argument, then we have an operation, then we have an argument, then we have an operation, then we have an argument, and so on. To get a nice view of this, we can go dis.dis. We resume 0 again. We did that before. Then we have this load fast command. Then we have pop jump if false. Then we have return const and return const. So let's see in a diagram. So we start again with resume none, because we're at the beginning of the block, and fresh new block. So we load fast 0. So from our locals table, here are our local variables. We load stock, which is the argument that we gave, that the user has to give to use the function. They have to give an argument stock. So this is loaded and put on the evaluation stack. Then we have pop jump if false, which is our leapfrog command. If stock is true, if we have stock, then we don't pop jump, and we return the constant 1 from the constant table, which is launch into space. So if stock is true, we return the constant 1, which is launch into space. But if it's false, then we jump 1 command. We leapfrog 1 command. So we leapfrog over this instruction and go to this instruction, which is remain in stasis. Let's make that a tiny bit clearer. So load fast pushes a reference to the co-var names, varnum, onto the stack. The value of stock is pushed onto the stack. This command pops it off the stack. Load fast has put it onto the evaluation stack, and then pop has taken it off, and then jump if false. Take that, put it on the evaluation stack, then pop it off, and if it's false, skip the next line. So this is how many lines to leapfrog. So we're going to leapfrog, how many instructions to leapfrog. So we're going to leapfrog 1 instruction. Well, that's a good intro. There's a lot more I want to say. I think that's enough for today.